Hi, everyone. This is Michael Lee. I'm the founder of the Data Incubator, and welcome so much to the next installment of this series entitled Data Science in 30 Minutes. Before I speak a little bit more about the series, I just want to say a little bit about the company, Data Incubator. So we run a fellowship that helps PhDs and master's students who are looking to make that transition into industry as data scientists. The fellowship is completely free for fellows who get in. And if you're interested in learning more about the fellowship, you can apply online at www.thedataincubator.com. And you'll also find there a lot of resources about not just joining this data science fellowship, but learning more about getting into the data science industry, and lots of resources about sort of projects and sort of ways you can learn more about data science just on your own. We also do a lot around corporate training for data science, and if you're interested, I'd also advise you go to thedataincubator.com and check out our website. So today we're back with another installment of our regular monthly series, Data Science in 30 Minutes. And we're just talking about data science in the world and also different people's careers in data science and how they made that progression as their careers advanced. So we had previously Becky Tucker, who is a data scientist at Netflix, Jess Strofe, who's the VP of data at Quantopian, Holden Corral, who is an engineer at IBM and a core contributor to Apache Spark, Andreas Mueller, who's one of the creators of Scikit-learn, Sam Swift, who was a data scientist at Betterment, and also a former TDI fellow. And we've had a number of very distinguished guests on top of them, and we're looking forward to having another one today. Now, before I introduce today's speaker, I want to remind everyone that you can pose questions in the YouTube chat area. We'll be monitoring that, and we'll be posing your questions to the speaker at the end of this session. In order to be able to pose those questions, I think you have to be logged into your Google account, so I suggest you do that. And without further ado, I'd like to introduce today's speaker. So Katrina is the director of core data science at HomeAway.com. And over the course of her career, she's worked extensively in fields such as scientific computing, machine learning, data mining, and visualization. And most notably, she's worked on classifying submarines from SONAR data when she was at UT Austin, fighting credit card fraud at Apple, and leading efforts at DARPA investigating human trafficking. And those are also pretty exciting things. She got her PhD in computer science with a concentration in AI from UT Dallas. And we're really excited to hear all the things that she's done in her career and how she got to where she is. So Katrina, do you want to take it from here?
Sure. Thanks, Michael. I really appreciate the introduction. I just wanted to kick things off and talk a little bit about my journey as I've moved into this realm of data science. It's certainly been a circuitous path because at the time that I was trying to figure out what I wanted to be when I grew up, there was no such thing as a data scientist. There was no path really to follow. And I really, had to feel this out as the industry emerged and found opportunities as they came along. So I was just going to kick things off to talk a little bit about 20 years ago. Okay, so that was around the time that I was introduced to this programming language called Python. And this was my first foray into actual computing and programming. At the time, I was a molecular biology student, and I worked in a population genetics lab. So through the course of introduction to this programming language, I felt like this whole world had opened up to me, where suddenly I became very interested in programming, very interested in learning more about how computers work, more interested in how we could use computers for simulation, and especially working as a bench scientist, how we could use it to crunch these enormous amounts of numbers that we had in front of us and mine it for information. This led me into a whole path of switching over to the computer science department, pursuing my PhD in computer science. My first job, I should mention, was at a small research and development company that focused on artificial intelligence technologies. Very fortunate to make that introduction. We worked primarily on semantic search and also legal support packages for data discovery, things like that. And
how did you get that first role or that first job?
Oh, that's a great question, actually. So I was an officer in the ACM chapter on campus, and one of the founders of the company came to give a talk about Python. We got to talking because I was already an enthusiast, and they mentioned that they had been looking for either part-time help or interns in order to work with them. So instead of posting the job, I basically asked them if they would consider talking to me. And they interviewed me and gave me a job. That was my first job as an actual programmer, working with them. And then moved on after I finished my master's degree. I joined them full-time as a full-time software developer.
And now this must have been in the really early days of Python, right? We're talking like NumPy pre 1.0?
It is actually even before NumPy. So we were using numeric at the time. So we were really before a lot of that. We watched a lot of these technologies grow up. I remember being very excited about trying NumPy, learning more about NumPy and figuring out, where this is going, because especially in the scientific computing area, this was a huge advancement for all of us, right? So just kind of as a spectator and scientific computing enthusiast, that's kind of where I fell into place. Yeah. So from there, I actually decided I'd go ahead and pursue a PhD in computer science. The lead researchers at the research and development company all had PhDs. It seemed like the natural progression in order to become a full-time researcher and really, stay in that research area. We were working on new technologies, new ways of doing AI, new techniques, developing new algorithms, things like that. Is before we had the huge machine learning boom that came later. So, which I'll get to in a minute. But so we were really trying to make this company take off, and I was very fortunate, I think, to have this as my first experience. While I was getting my PhD, I joined the artificial intelligence lab on campus. So I was a research assistant in the laboratory there, and just smooth sailing through there, and went on to get my PhD. But during this time, actually, the research and development company sadly went under. So I was unable to rejoin them, and suddenly was faced with the possibility of finding another job. All of my skills were around artificial intelligence and scientific computing at this time. And I have to say that, this was probably around the 2006 timeframe. I hit a little early, right? So finding jobs in artificial intelligence, finding jobs in machine learning, these didn't really exist at the time. It was very difficult to find anything even close to that area. A few shops were really starting to play around with it. Google was starting to show some signs of, AdWords and things like that, but there weren't a whole lot of opportunities out there. And so I relied mostly on my Python skills, right? So I joined a company here in Austin called Enthought, that is a Python consulting business, and worked with them mostly on visualization. So working in that area on scientific applications, putting together visualizations. From there,
it's somewhat fortuitous, right, that you happen to be in Texas, although I guess in Dallas, and not too far from you is probably the home of scientific computing, so to speak, with Enthought and the creators of NumPy and SciPy right there.
Right. I actually was very fortunate. I met a lot of the employees at Enthought actually at PyCon. It was being hosted in Dallas in 2006. And I was there as a volunteer and met several employees from NTHOT and was very impressed with them. And, you know, like you said, it's just kind of down the road. I am a native Texan. I love, you know, being in Texas. So it was I feel a very natural progression to move down to Austin and join NTHOT.
Cool.
So while I was there, the open source packages primarily were Chaco and Enable, the visualization. So for interactive plotting, they had libraries for particular UIs. And while I was there, the industry was starting to kind of gear up a little bit. You're starting to see more movement in the machine learning area. You're starting to see more movement around AI. People, so my next opportunity was very fortunate. I joined the Applied Research Laboratories at the University of Texas at Austin. We were working on active sonar. So there's a project that with the US Navy where we were trying to classify active sonar signals in order to detect threats in the water. So that was my first foray into actually working at a classifier at scale, custom built, programming all of the algorithms from scratch, primarily, by the way, in C and C++, a little bit of Fortran. So I know that kind of dates me at that point, but.
And I was going to say, this is also before MapReduce, right? So when you're working at scale, you had to deal with your own kind of parallelization.
Yeah, so that's a good call out. This was before MapReduce, this was before Hadoop, this is before a lot of the big data systems that we see today. So we had a lot of memory management and ways of caching data in order to be able to handle these large amounts of data in near real time. On top of that, you know, just making results available and being able to do analysis on the sonar signal was also a bit of a challenge because we would have to build custom tools around that. And luckily, you know, visualization background comes in handy, right? When you're trying to visualize all of this data, work with the data. And so we built a lot of tools on top of it so that people could actually look at sonar signal.
Interesting.
It was a fantastic opportunity. I loved my team, loved the lab. I loved being in that academic / you know, experimental environment. Although the classifiers do end up in production systems. So we work with an integrator who would, you know, actually would make things available and deploy them out onto the ships. So it did give us the opportunity to work on production level systems. From there, this was my first chance. I was there for several years, and when I left the lab, this was my first time that I was actually called a data scientist, by the way. So I got my first job as a data mining scientist at Apple. And so this was a huge change. I remember at the time kind of, you know, I'll just be honest, just kind of laughing at the title, right? I mean, what is a data scientist, right? What does that mean, right? And especially worked as, you know, a lab technician and a lab assistant and working with, you know, bench scientists and things like that. What was a data scientist? What was this thing? And why, how did this happen, right? But it covered all of the bases of things that I had been doing, you know, working with, you know, large amounts of data, doing machine learning, doing large-scale analytics, things like that. So combining all of that together as well as the visualization piece on top of it. And it just all came together, right? I think in some ways I still, you know, relied on my software engineering and software developer background at the time, much more interested in, you know, deployment and platforms and making things fast and optimized and things like that. But at the same time, it was fascinating to me to see how data could be used in organizations and how it could affect decision making, as well as, you know, what kind of impact you can make on a company, right? And I think this is around the time that I really started to wonder, like, okay, am I a software developer? Am I a researcher? Am I a, you know, or am I this thing called a data scientist, right? And I think that the answer is pretty clear. I really began to embrace that idea of data science as a discipline, that this is a necessary discipline that needs to be explored and developed. It does have all of these different components to it, right? Where you have the mathematics background, and you have the visualization background, you have the engineering background, and very strong machine learning background, right? They all kind of come together in order to support this new way of thinking about data, new way of doing business, really, right? And I loved that ability to make impact. I love that ability to find insight and really make it actionable. And so this was around the time that I think I really started to get on board with this whole.
I think that's sort of what's interesting, right? So you come at this with a computer science background almost. But I think there's something about when you marry the computer science, the data, and the statistics or mathematical aspect to things, that you're able to sort of have this view onto how the company kind of works as a machine almost. And that view is incredibly valuable to business stakeholders. And it can be really powerful, especially in these sort of digital first companies like HomeAway or Apple. It can be really, really powerful and impacting the bottom line and kind of transforming the way the business works, really. And that's something that's, you don't quite get with any of the pieces, but somehow you do when you put the pieces together.
I agree. And this was always a challenge for me, right? I talk a lot about the trifecta, right? We have data mining, machine learning, and visualization as the, parts of the pyramid that all have to build, they all have to be there in order for this to work. I can't tell you how many times I would, spend months putting together some sort of model or, training up some sort of system, and people say, oh, okay, like, can I see what you've been working on? And I press enter on my command line and it spits out a whole bunch of numbers. I'm like, see, look, it worked. And here's the answer in this unintelligible way that makes sense to you, right? And doesn't actually guide you or make it any easier for you to make any kinds of decisions. At the time, I was working a lot with medical diagnosis, and as you can imagine, all these statistics pop out on the screen, and you see all of these, satisfiability problems and, machine learning algorithms and, statistics that pop up, and it's pretty unimpressive, right? How does one make that accessible? How does one make that actionable and insightful? And so, it just took a while, I think, for all of these different pieces to fall into place for me, right? Where I really started to see the connection. And so moving forward in my career, that was something that I very much embraced, where you have the visualization part to make data accessible, make it easy for people to understand what it is that they're interacting with, and be able to have engagement, like real engagement with what's going on. Real insight that is novel and interesting, on top of being able to predict and make, to aid in decision making, right? And so the next major project that I worked on after Apple was actually the DARPA Human Trafficking project. And that was where we were actually, if you're ever interested, it's called the DARPA MEMEX project. It was primarily started to talk about fighting human trafficking, but they did a novel thing where they put a lot of the software out in the open source space. So by making this accessible, the idea being to leverage the open source arena and make all of these tools available and accessible for people to use. So the data was not necessarily shared, but the software is, and that, I believe that website is actually still up and running. So, in that area, you could see, automated training of models, directed crawling, where you could actually say whether pages were relevant or irrelevant for particular areas where you're trying to investigate, and training models on the fly and making it visual and interactive and something that people can actually work with. And that was a big, that was really the first project where I felt like everything came together, where we were able to take the software engineering side, take the visualization side, take the machine learning and the real, hardcore data mining, put it together into this. Yeah.
Let's. I want to make sure we have a little bit of time to go through people's questions. And obviously, talking through all of these projects and you're bringing together all these skill sets, I think a natural question comes to mind is, how do you break up what you've learned into what you learned, let's say, formally in school in your PhD, say, when you're on the job as a part of that job, or just kind of like on your own after your PhD, because you've been doing sort of fun side projects or just reading for fun?
Right. That's a great question also. I think in school, I learned the fundamentals of computing. I understand how computers work. I learned how to make things fast. I learned how to, build systems that are fast and optimize algorithms and do all of those things that are necessary for compute. And I also learned the fundamentals of artificial intelligence. But I think that, part of my personality is I'm a very naturally curious person. I have always—
I think it's true for most of us.
Yeah. I've always had side projects. So even when I was in school, I was constantly working on robots in the background. So working on a lot of robotic control systems, experimenting with what I could do in that arena. An example, I think even, working with the SONAR, I became obsessed with understanding SONAR, right? I got to go to active SONAR school and be trained along with people in the Navy, which was pretty exciting. And really understand what it is that I'm looking at, really understand the signal, really understand the physics of how signal moves through water, right? And that all could inform how I thought about modeling these problems and what kinds of things have to be taken into account. And I think it's that depth that is necessary for us to really understand data, for us to really be, we become subject matter experts. We have to, right? We have to have that special sense of like what it is that we're looking at and really understand the data very, very well. And that was something that I think came very naturally, where I would just get really involved, right? And pick up everything I could. I also have to definitely mention the open source community, right? So being involved in open source, being exposed to great programmers and software engineering practices and new ideas, right? These were all things
incredibly important.
Right. So I feel like in some ways, I learned programming practices on the job. I learned programming practices being on open source projects. I learned about new techniques, new ideas, being a part of communities. And that was so helpful to me and continues to be very helpful to me to understand that cross-pollination of ideas. And yeah.
Yeah, so through your multi-decade career, you've worked on a lot of different programming languages and sort of tools. And we touched on a few here, but I'm curious, for the folks listening now who are thinking about becoming data scientists, what's the programming language of choice that they should be learning? What's the tool what are the tools that you find most effective today?
Sure. In the data science space, I've actually, having gone from coding algorithms by hand in, C and things like that.
Did you have a copy of numerical recipes?
Right, I did.
You would copy it off. You would copy the code carefully. Hope you didn't make any mistakes. Open source was very, very rudimentary back then. It was copying from pieces of paper.
And but I think definitely on my team, I encourage people to try new things, right? So obviously I am a Python enthusiast. I think a lot of data scientists are learning Python. R is also very important. Understanding R. There are R packages that I just absolutely adore and will never.
What are some of your favorites?
dplyr. I love dplyr, right? Yeah. And I have to say ggplot. I still use that quite often.
The wiki versus large.
Yeah. And for a long time, I'm just going to go ahead and say it, but I mean, this really, but the random forest library in R was definitely the superior one, right? So I think that we've moved, scikit-learn is totally, caught up and has great implementation and everything like that. But definitely, 6 years ago or something like that, it was definitely the R implementation of random forest that was the one that everyone used. And so understanding, you know, all of these different nuances, but I would say that Python, R, Scala, people sometimes use Clojure, you know, we're really moving into those areas. But I think having outside knowledge of other programming languages also comes in handy, because we do have to integrate with systems that are possibly Java-based or some other programming language, right? So understanding how languages can talk to each other and how to create clean interfaces is definitely a skill in integrating machine learning into any application, I think. So I would say that I've, you know, touched upon almost every language I've ever I've ever touched, but definitely Python, R, and Scala are the ones that I see mostly with the data science team.
So I have this really interesting question here, and touches on something we talked about earlier. So from a career growth perspective, do you see data science as something that kind of eventually hits a glass ceiling, where at some point it's no longer considered a strategic position, and so you cannot move up in the organization further?
You know, so I go back and forth on this one. I'm just gonna be honest that,
Yeah.
you know, I see the trends and I see how accessible it's all become, right? We have these incredibly powerful libraries, and we have, you know, we're not quite technical, we're not quite business, we're not quite, you know, consultant, we're not quite, you know, it's hard to pinpoint where it is that the data scientist falls, right? And how we engage with everything. So it's interesting to me that I personally wonder sometimes, but then again, as being the kind of people who understand data, get to know data, and as a result of that, get so involved and become experts in their area, right? You can't help but pick up the skills that would be needed in order to be able to have strategic sight and business insight into where things are going. And those are the kinds of skills that I think are really necessary to be able to move up, right? So today I'm going to say, no, there is not a glass ceiling, right? That the data scientist has just as much opportunity to move up and be in leadership and strategic roles as anyone else. But I reserve the right to change my mind as I see it go.
Yeah. And I think that, you know, data is becoming more and more integrated in the way organizations are making decisions. So it seems that the trend of data science becoming more and more important. Seems like it's not going away. And I think we're seeing some examples now already of places, organizations, albeit sort of, let's call them digital first organizations, where data scientists are becoming CEOs. And moving into those kind of top tier executive C-suite positions.
Yeah.
So your background obviously is from computer science. We have a lot of people here who have non-CS, non-programming kind of backgrounds, and they're maybe, you know, pure math or physics. Those are very common backgrounds. I'd love to hear your thoughts on kind of how that impacts their careers as data scientists, because you've obviously worked with many, many young data scientists from a whole bunch of backgrounds. And then what are things they can do, the second half of this question is, what are some things they can do to help make themselves more presentable as data scientists?
Sure. So the first part of the question, I just want to address that I'm actually, I think, the only person with a CS degree on the data science team, right? And the people that I've typically hired do come from quantitative backgrounds. So, I mean, everything from, you know, physics, operations research, economics, you name it, as statisticians, mathematicians, all the way through all of these quantitative fields, right? In some ways, I wonder sometimes, you know, this is part of embracing data science, right? That letting go of that identity as being the engineer, right? That I really am filling a data science role and developing those skills, right? And so that leads to the second part of the question, what you can do to make yourselves more accessible, more ready to be a data scientist. I think the main thing is obviously just getting involved, right? Work on projects, get involved in data, work on things. I love when I see people with GitHub repositories, and I do read them. I go through and see how they think about it, and are they just throwing compute at the problem, or are they actually thinking deeply about the features that they're putting together? Do they show an understanding of the data and things like that? And so I think that those types of things are very important. And then also just working on, presentation skills. We are communicators, right? It's not just working with the data. It's not just finding insight in the data, and it's not just predicting what's going to happen in the future. We have to tell the story of where things are going and make it accessible in a way that people can make decisions and use that insight for actionable initiatives inside the company. So working on those two areas, I think, will help quite a bit.
Got it. And then are there any particular sort of technical skills that you think are important for people to be pursuing?
Right. Well, I guess being a computer science major, maybe the bar is a little higher on my team than average. I do want people to have a basic understanding of how to code. I want them to understand, basics of good software practices and how to be able to put together software in a way that makes sense. Obviously not at the same level that you would expect from a software developer, somebody who writes production ready, fault tolerant code. But I definitely want people to have a decent understanding, because I also don't want our team to have to be, this is going to move fast. We're going to see new things coming down the pipe quickly. I want people to be able to adapt and be able to use technology and not be afraid of it. And so that, I think, is going to come up more and more. So I want people to have, a good solid basis in technical knowledge, right?
Got it. So I think we're at the end of our 30 minutes. I wanted to thank Katrina here for coming and taking the time to speak. We really enjoyed having you on. I want to thank the audience for coming and attending this webinar. I know there's a few hundred of you out there. We're really excited to have you be a part of this conversation. And lastly, I just wanted to make a brief plug. If you are a PhD or master's student looking to make that transition into a data science career, you might want to consider the data science, the data incubator. We have a free data science fellowship that's targeted towards people like you. And if you're already a working professional, you may want to consider some of our online courses that cover everything from the foundations of data science all the way up to advanced topics like deep learning and TensorFlow. And of course, if you're interested in corporate training, we also have lots of corporate training options. And if you want to find out more about any of those three things, our free fellowship, free data science fellowship, the online courses, or the corporate training, you can apply online on our website, www.thedataincubator.com. So without further ado, I'd like to thank Katrina for being here. And I guess we will see everyone at our next installment of Data Science in 30 Minutes.
Thank you.
Cheers.